Yes, I want sand and I want shells. Oh, cool. Okay, these are the parent functions. We learned those yesterday. You all good with them? All right, let's now transform them. Today we're going to focus on stretching them vertically, and we're going to focus on stretching them horizontally. We will also talk about reflecting them over the x-axis. Actually shifting them, that's going to happen tomorrow and Friday. That's the hardest content that you have for this unit. It's just 2 sections, 5.3 and 5.4. And so if you could get through that, you're going to be good to go. Okay, you're a lot of A's on this test last year. This is a chance for you to really redeem yourself if you didn't do very well on one of the previous 2. Let's identify this. The amplitude is simply going to be the absolute value of A. Whatever coefficient is front, that's going to determine how far it's stretched above or below the x-axis. The period is how often it repeats itself. That's 2 pi divided by the b value. So whatever value is in front of the x, that's going to be the period. It's the same for sine and cosine. The only difference between sine and cosine is that one is shifted over. It's actually a shift of pi over 2 units. So for our first set of problems, we are going to be looking at actually identifying the amplitude and the period. This maps exactly to what you're going to have to do on the first part of your test. As well as your study guide, you're going to be asked to do this. Forget about that. I used to do that. You guys are smart enough I don't need to do that anymore. Find the period and amplitude of the following graphs. 2 sine of 3x. What is the amplitude? 2. What's the period? 2 pi over 3. Easy peasy. That's it. There's a catch. I don't know. No. I suppose maybe. Amplitude, how about this one? 3, absolute value, so positive 3. The period? Pi divided by a fourth. 8 pi multiplied by reciprocal. 8 pi. There you go. That would be the only catch. Is that, if you're dividing by a fraction, know how to work that out. So like this one right here, we've got negative cosine of 2 pi x over 5. Amplitude is 1. So what does the negative do to it? What flips it over the x-axis. And the period is going to be 2 pi divided by 2 pi over 5. Well, that's like 2 pi over 1 times 5 over 2 pi. So again, as Hannah said, you could multiply by the reciprocal. So what's going to happen? Yeah, some students struggle with this. They're like, well, every period has to have a pi attached to it. No, if there's a pi in here, then it will just divide off. And we could just stick a decimal in here too. You stick like 1.85 or square root of 2 or whatever you want. I mean, you can use any type of real number. Question. Always 2 pi. And the reason why is 2 pi is the basis for the period for the parent function. So that's always where we start with. Sine and cosine repeat themselves every 2 pi. So that's where we start. So if you notice, if there's an integer in here that's greater than 1, it will repeat itself, 2 pi over 3. Is it going to repeat itself more often or less often? More often. Okay, it's going to repeat itself, actually 3 times as often within that given interval. Whereas look at this. Here we have pi over 4. Is it going to repeat itself more often or less often? Less. So if you have a fraction like 1/4, now instead of repeating itself every 2 pi, it repeats itself every 8 pi. So 4 times less often. What up, dog? Yeah. There you go. Okay, amplitude for D. What do you got? 1/4. Good. And 2, don't write the negative. I'll mark it wrong on the test. Just make sure you understand that amplitude is always positive. Okay? Then the period is going to be 2 pi divided by, which is 2. Any questions? So can you do that? Okay. You don't have any questions like that in your homework, but that's going to be the first part you're going to be asked to do on your test. 3, describe the relationship between the graphs of f and the graph of g. Consider the period and the amplitude. A, what's the amplitude for f? 1, what's the period? 2 pi. G, what's the amplitude? 1, what's the period? Pi. So, what is the graph of G going to look like compared to the graph of F? Not 2 times as big, but it's going to repeat itself twice as often. G will repeat twice as often. And is reflected over what? And is reflected over what? X-axis. So G will repeat twice as often and is reflected over the X-axis. Somebody tell Jensen why we know it's reflected over the X-axis. Negative on the outside. What if the negative was in front of the 2? Reflected over the Y-axis. And we really try not to deal with that. There's just other ways to write it that make it simpler, so try not to think about that. Not very applicable for us. Okay, the next one. What's the amplitude for F? 1. What's the period? 2 pi over 3. Good. For G, what's the amplitude? 4. And what's the period? So the period is the same. So they'll repeat themselves just as often. Okay, so no change there. So what is different about these graphs? G is stretched by a factor of what? 4, and is reflected over what? X-axis. See, you guys already know all of this, don't you? I mean, just think about it. We're doing trigonometry now. We're doing sine and cosine. Do you remember early in the year, I handed out this sheet that looked like this. Y equals A F of BX minus C plus D. Remember I handed that out and we said, well, what does that do? That's a vertical stretch. We said, well, what does that do? That's a horizontal shift. And then this is a vertical shift. Well, you guys, we're just going to do Y equals A times sine of BX minus C plus D. You know, we're just going to do that same piece. So it may look complicated, but you've already done it. That's already in there, and that's why we did it. And you could do that with any type of function at all. Any. Okay? All right. Cool. Let's go. Back a page, we are going to... Oh, take out your graphic organizer. Did you take it out? I want this one right here. I want the one that has the graphs. That's the one I want right now. Whose did I take? Julia's? Okay. So do you see right down here at the bottom, first of all, on top you have the sine and the cosine graphs, right? The x and y axis doesn't make it in there very well. If you want to draw those in, go right ahead and put little markings on it. You can do that. But also, if you look, it says sine and cosine, and it gives you all the descriptors. Amplitude is the absolute value of A, and the period is 2 pi over B. I give you this on the test. And some people may say, well, why would you give that on a test? Honestly, you're going to know this stuff well enough that you probably won't even reference this. But this is a nice sheet of notes to have that summarizes all of your learnings. And yes, we will do tangent, cotangent, and cosecant, and secant. Secant looks kind of bad, doesn't it? And cosecant, as you look at all the notes there. I'm going to tell you right now, it's not bad. As long as you know how to do sine and cosine. Today, tomorrow, and Friday are essential. All the learning for the rest of the section will be based off that. If you can learn that, you'll be good to go. Okay. All right. You guys are super smart, which makes a big difference. We're on a good path. Let's just start by doing this right now. Steps for graphing. Number 1, we identify the amplitude. It's previous page. So we just spent a lot of time looking at amplitudes and periods. So today we're just going to look at A and B type of shifts. And so what's going to happen is we're going to look at the amplitude. We're going to look at the different types of graphs. We actually want to graph these down. And a lot of people, when they see these, they're wondering, where do I start? Here's where you start. Amplitude. Once you find the amplitude, mark the max and the min. Mark the maximum minimum spots on the y-axis. After you have that, then we go to number 2. Find the period. And divide into how many pieces? How many pieces do we divide the period into? 4. Why? Yeah, 4 parts. Each part represents one of the quadrants because it takes all 4 quadrants in order for sine and cosine to repeat itself. 3, locate starting point and direction. Helps to see it again a second time, doesn't it, Kelly? You know, it's like, it's all there, isn't it? But now it's the retrieval process. So I remember feeling the same way sitting through another class. All right, so let's actually make it happen now. Let's graph it. Y equals negative sine of x. I start, first step, I identify the what? Amplitude, what is it? 1. So I mark off 1 and negative 1 on my x-axis, or on my y-axis. That's the top and the bottom. We did a problem just like this today in calculus. We went through the same procedures. Then second step is I identify the period is 2 pi. And I put that down on the x-axis and I divide it up into 4 parts. I like to put one over there as well because I got room. You can do whatever you want. You can rip your notes up and burn them if you want. Okay. Third step is I identify the starting point and the direction. Does sine start at 0 or does it start at a max or a min? Starts at 0. Now, will it start by going up or will it start by going down? It normally starts up. Because it's got a negative, it's reflected over the x-axis, so it's going to start by going down. So my starting point is here. Now, when I taught regular track trig, a lot of people had problems with these next steps. Okay, so if you have questions, ask me. But we went over this yesterday. Okay, so we'll see if we can make that learning. If we're going down, then at this quadrant, pi over 2, what is going to be my y value? Good. After I reach that bottom, because that's the minimum spot that it's going to attain, right? So what direction does it have to travel now? Up. And so is it going to, is my next spot going to be at a height of 0 or a height of 1? Yeah, I got to go to 0 first. And then my next spot I'm going to go to 1. And after I get up to 1, then I'm going to go back to 0. And And, you know, you could copy this on the other side then. You know, if you go the other way, you could see, oh, well, if I go back, then I would continue the pattern and I would go up. And then I would come back down over here. You know, you can see the shape that you get, right? So once we plot those points, it's going to be really easy for us then to draw the shape. See if you could draw as good of a wave as I can. I practice this, so. I try to have my kids drawing sine waves when they reach about 4, so. See, I could teach Micah right now, what's the derivative of y squared? And he could say 2y. I mean, I could teach him to do that. I mean, he has no idea what it means. But he, probably not. He's a little slow. All right. Take out your calculator. Let's graph it. Let's see. Let's see if we match it up. I want to show you guys how to put this on your calculator. Okay, so I go into y equals, and my graph was negative sine of x. So I go negative and sine of x. And remember, are you working in degrees or radians? We're working in radians right now. Anytime you put something on a graph, you are working in radians. If you're working in degrees, then you're going to be stretching that shape out 180 over pi times, okay? That's a lot. Okay, you don't want to stretch it out like that. That's just bad. So let's change it so we're working in radians. So mode, make sure you're working in radians. Everybody good? Okay, then I go back to my window, and I want to view exactly what I have on the screen to see if it's right. So you tell me, in my drawing, what was the smallest x value that I had on there? Like a negative pi over 2, right? So I'm going to go negative second pi divided by 2. And it just puts it right in there. It'll convert it to a decimal as you move along. What was the biggest x value I had in there? 2 pi. 2 second pi. What's up? Indy! Okay. Scale. How often is every tick mark? Pi over 2. Good. Pi divided by 2. What's my biggest y value? 1. No. Oh, yes. But my smallest y value is negative 1. Biggest y value is 1. Just won't mess that up. We got to scale every one. I don't know what x res is. I've never really thought about that. So. Okay. Everybody good? X scale is pi over 2. Got it? Graph. Are you working in degrees? You need to be working in radians. Are you sure? Okay, if you hit go to, it's going to take you to your window and help you figure that out. You got a minus sign instead of a negative sign. So go over there and hit negative. There you go. Well, you guys can see I've got the same shape, right? So when you're checking your answers today, when you're doing your assignment, make sure that you just graph it and make sure it's the same. Now, I'll tell you this. A lot of your answers are going to look like waves, but what's going to make it difference is, you know, your type of markings that you have here, your scales. This is the part on the test that you have to make sure you mark correctly, is your scales, because that's how I'm going to base your graph and judge it. All right, you got the one example. The others go pretty quick. What's the amplitude for for this one? If you're working in a problem that involves degrees, if it says like 78 degrees, you need to take the tangent of it, then yes, you got to move back to degrees. Okay, what's the amplitude? 3. All right, so I mark off the top, which is 3, the bottom, which is negative 3. And what's the period? 2 pi. 2 pi divided into 4 parts. Okay. So So I got my first two steps done. My third step is identify the starting point. Does cosine start at 0 or does it start at a max or min? It normally starts at 1, which is like the maximum value. But if we multiply it by 3, then it's going to be up at 3. So it starts all the way up here. And which direction is it going to go? It's going to start by going down. Whereas if there was a negative in front, it would start at -3 and it would start by going up. Okay, so after I have a spot here, where am I going to be at pi over 2? 0. How about at pi? 3 pi over 2? 2 pi. Okay, and then you can, go reverse and continue on just like that and yada, yada, yada. And you can see if you can draw a better graph than me, which is almost impossible. And then I could go to my calculator. And I'm going to do this real quick just because I think it's a lot of fun. If you want to, you can. You don't have to. I type it in, and I go to my window. That's all the same, but the min should be -3, and the max should be +3. And I graph it, and would you look at that? Identical. Right? We did it. Pretty quickly, too. I bet somebody want to time us on this next one? Who wants to time us? Okay, Hannah, you say ready, set, go. Amplitude. Top, bottom. Period. Good, 2. Divide it. Everybody got that? Got to locate the beginning point. It's a sine function. Does it start at 0 or does it start at top or bottom? 0. Is it going to start by going up or going down? Up because it's positive. Where am I at 1/2? 1. 3/2. 2 to 0. Can back up from there. Draw my sketch. And Hannah, what is my time? We did it at 55 seconds? Oh, I thought we'd take at least a minute. Look at that. Is that a new record? Should we try? Well, I could try to break it, but I'm worried that I might be going too fast for the class. You know what I mean? Not? Okay, you want to try to do this one super fast? Oh gosh. Okay. All right, but the rule is that if I ask a question before I move on, you got to answer. So I'm moving at your pace. Okay. You tell me when to go. Amplitude. Top is 2. Bottom is? Period. 6 pi. Good. Divide up into 4 pieces. Halfway is 3 pi. What's this one right here? 3 pi over 2. What's this one right here? 3 pi over 2 plus 3 pi, or 6 pi over 2 is 9 pi over 2. Its cosine, does it start at top, bottom, or 0? Normally it starts at the top. You got a negative in front of it, so it's going to start at bottom. At 3 pi over 2, I'll have a height of 0. 3 pi, 2. 9 pi over 2, 6 pi. Sketch my unbelievable graph. Oh, go! That one's a little bit harder, I guess. Well, we better talk about this, though. How did I get 9 pi over 2? Watch what happens. Everybody see how I got 3 pi over 2? I divide 6 pi in half to get 3 pi. I divide 3 pi in half to get 3 pi over 2. Now, each one of these intervals has a width of 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is 3 pi. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, or 6 pi. So just add this one up until you get that spot, and that's all you do. You could graph it on the calculator, come out the same. You got a homework assignment, and you could get a lot of these problems done pretty quick, because each one only takes you 55 seconds. You got to do it the best. I don't have graph paper for you. Sketch nice, neat graphs, okay? And that should be all you have to do. Check the answers on your calculator. Use your graphic organizers. This test, I will actually be timing myself when I grade it, because I hope that there's that many A pluses where I'm just like, oh, boom, 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 done. Boom, 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 done. Yes. Happy birthday, Casey.